Coming up next, we dive into a powerful display of military aviation and ground operations. As the tracked vehicles roll out, a fighter jet demonstrates rapid takeoff capabilities. The Coast Guard helicopter maneuvers for a land.
The UH-60 Black Hawk entered service in 1979, delivering a major leap in U.S. Army utility aviation capability, replacing the UH-1.
It offered greater lift, improved survivability, and enhanced avionics. Its twin engines, composite rotor.
The aircraft efficiently transports troops, cargo, or casualties, remaining effective in extreme climates.
Its widely exported variants support militaries globally in medical evacuation, special operations, maritime. Crew members perform final checks on the rotor and engine components before taking to the air.
A typical U.S. Army Black Hawk assault squadron fields around 15 to 20 aircraft, depending on the unit structure.
Some aviation battalions group multiple Black Hawk squadrons to provide a larger lift and enhanced mobility capacity.
The core mission of this aircraft is troop transport. As you can see, the infantry is ready, equipped for any challenge ahead.
A standard UH-60 Black Hawk carries about 11 fully equipped troops in its primary assault configuration.
From securing the cargo inside to the final checks on the tarmac, a successful launch requires seamless coordination and collective effort.
Mass troop lifts use multiple Black Hawks launching together to rapidly insert large infantry elements into contested areas.
Every detail matters during pre-flight. We check the collective response and monitor the engine parameters closely on the tactical display before spooling up.
Coordinated formations allow dozens of helicopters to move entire companies or battalions in tightly synchronized waves.
Mission planners sequence routes, altitudes, and landing zones to minimize exposure and maximize ground force cohesion.
As the rotors engage, the final checks are complete. These Black Hawks are ready for a synchronized mass takeoff, a display of overwhelming force and precision.
Air crews maintain strict spacing and communication to ensure safe approaches during high-density airborne movements.
The synchronized air assault launch is a display of overwhelming force and precision. It requires intense focus and training.
U.S. Army air assault units in the 101st Airborne Division routinely use Black Hawks for rapid infantry insertion.
Air mobility is the cornerstone of modern military doctrine, providing the necessary speed to dominate the battlefield.
Infantry brigades in light divisions rely on Black Hawks for mobility in training and combat deployments.
The sheer scale of this air-powered display is unprecedented. Dozens of these Black Hawks working in precise coordination.
National Guard aviation elements support infantry battalions with lift missions during emergencies and overseas operations.
The staggered, looser formation isn't accidental. It's a calculated tactical maneuver that's designed.
Formation flights allow commanders to reposition entire infantry companies quickly during high-tempo air assault operations.
When flying in close proximity, strict adherence to separation protocols is essential. Air discipline prevents
Air crews maintain strict separation and radio discipline to prevent collisions during dense multi-aircraft movements.
Route planning uses terrain masking, timing, and altitude layering to reduce exposure to enemy observation and fire.
Mass landings place multiple Black Hawks onto dispersed zones within seconds to deliver troops in coordinated waves.
The next phase involves strategic bombers like the B-52. Maintaining rapid alert readiness is key, requiring immediate response from ground crews and support staff.
Crews manage rotor wash and tight spacing to maintain safe approaches during high-intensity insertions.
The urgency of the scramble drill is absolute. When the call comes, these crews have mere moments to get the B-52s airborne.
B-52 scramble exercises test rapid bomber launch capability during high-alert nuclear or conventional readiness drills.
With time of the essence, the crew must reach the aircraft and get the engines spooled up in record time. There is no margin for error.
Crews race from alert facilities to the aircraft, executing engine start and taxi sequences within strict time limits.
The mass movement of these colossal B-52 bombers highlights the logistical precision required to launch the formidable Stratofortress.
Cartridge start uses small explosive charges to spin the B-52 engines rapidly without relying on external power.
The high-pressure gas release drives the starter turbine, a unique procedure for the B-52.
Engine start is complete. Clear to taxi. Over.
The charge releases high-pressure gas that drives the starter turbine, initiating engine rotation almost instantly.
This method enables extremely fast engine activation during scramble situations where every second matters.
As you can see by the detailed fuselage, particularly the main gear here, aircraft 0118 has seen extensive service.
An elephant walk showcases many aircraft taxiing together to demonstrate unit readiness and rapid generation capability.
This is the elephant walk, a truly massive display of coordinated air power stretching for miles down the taxiway.
Minimum interval takeoff launches multiple aircraft seconds apart to generate rapid airborne combat power. The B-52 demands maximum effort from its engines, leaving a trail of smoke as it claws for altitude.
Crews accelerate timing to maintain safe spacing while maximizing departure speed under high alert conditions.
As you can see, the bomber is in full combat configuration. It's carrying a significant payload on both the wing pylons and the fuselage.
The technique supports surge operations, where fast runway clearance and continuous climbs are essential for survival.
The Stratofortress, captured in this dramatic high bank, ascends rapidly, soon joined by its comrades in a display of overwhelming force.
E-52 smoke trails come from older engine designs that burn fuel less efficiently during high power settings.
Ensuring the safety of the airfield is a 24-hour operation. These security forces implement strict protocols.
Security forces clear the B-52 parking area by checking for hazards, ensuring safe taxi paths, and enforcing restricted access.
The ground forces stand ready, equipped for any contingents. As the B-52 arrives, their focus remains steadfast on the mission ahead.
The B-52 relies on a powerful drag parachute to rapidly slow the aircraft after touchdown on long, heavy approaches.
Gripen Alert scrambles launch within minutes as pilots sprint from readiness shelters directly to armed aircraft.
With unmatched speed, the pilot transitions from the armored vehicle straight to the cockpit of the JAS-39 Gripen. There is no time to waste. Ground crews complete rapid start checks, enabling immediate engine ignition and fast taxi from hardened positions. As the pilot runs through the final systems check, the ground crew performs their own critical inspection of the landing gear. With the final ground checks complete, the Gripen is cleared for immediate departure. It can transition from Hangar Queen to airborne interceptor in a matter of minutes.
The fighter climbs quickly to intercept unidentified aircraft, supporting national air defense networks.
The Saab Gripen originated from Sweden's need for a flexible multi-role fighter suited for harsh Nordic conditions and rapid response tasks.
We focus now on the heart of the Gripen, the engine detail. The powerful rear view highlights the afterburner, creating this
The aircraft features short takeoff capability, enabling operations from narrow road bases during dispersed wartime deployments.
The Gripen is now fully committed to the launch. Look at how those forward canard wings are already providing lift, even at this speed.
Its modular design reduces maintenance time, allowing small crews to rearm, refuel, and relaunch the jet quickly.
Look at that climb. The Gripen just disappears into the clouds. And the agility, incredible. But what really sets it
Gripen integrates advanced sensors and data link functions, enabling coordinated engagements with nearby aircraft and ground controllers.
The fighter supports air policing, interception, strike reconnaissance, and maritime missions with a wide weapon selection.
The Gripen pilots demonstrate incredible teamwork, maintaining tight formation even through the dense clouds, showcasing true high-altitude capability.
During World War I, aircraft employed crude rubber tires, reinforced with cotton fabric on wooden wheels.
These modern military aircraft tires are immense, weighing hundreds of pounds each. Proper technique is essential for moving them safely into these high racks.
Multiply nylon cord tires that could withstand exceptionally high takeoff weights were introduced with the B-29 Superfortress.
The detailed assembly process begins with carefully seating the wheel halves. The crew then uses a power tool to tighten the bolts.
Advanced nitrogen-filled radial tires, suitable for carrier operations and heavy loads, are used by the modern F-35s.
The bolts are tightened to precise specifications using a calibrated impact wrench, ensuring structural integrity.
Modern U.S. Air Force tires are comprised of numerous layers of rubber, cloth, and steel to withstand heat, wear, and impact.
Tire shops are present at U.S. Air Force bases across the world for easier intermediate maintenance. The role of a modern tire shop goes beyond just changing tires. We focus on the specialized process of maintaining the wheel and rim assembly.
Tire shops have at the very least tire rimming facilities used to attach and remove tires from rims.
As you can see, the hydraulic clamps secure the wheel, and the machine applies precise pressure to seat the bead firmly against the rim.
Greasing is important before bearings are placed inside the outer rim to reduce the extreme friction involved in landing. Now we use the press to slowly guide the bearing into the housing. Precision is key here to avoid any damage.
Wheel bearings are critical to ensure the wheel rotates evenly with reduced friction on the axle.
As the final bolts are laid out, the team works in unison. Securing these components is critical before the final torque.
Aircraft maintenance technicians are responsible for aircraft structural maintenance, such as working on wheels and tires.
Advanced wheel and tire lifting devices are used to ease the manual load experienced by aircraft maintenance technicians.
As you can see, the precision gripper secures the tire completely, demonstrating the sheer strength and safety of this technology.
Tires for the C-17 are about 4 feet in diameter, and the C-5s are 4.7 feet, making them difficult to handle manually.
The installation of these massive rims requires precision and a coordinated effort from the crew. It is a delicate balance of force and finesse.
Tires are placed inside a tire inflation cage or tire safety cage for inflation to protect personnel.
Safety is paramount. The tire must be fully housed within the cage before inflation begins, and the heavy door secured with this reinforced latch.
Aircraft tires are inflated much more than car tires, so a tire burst can cause serious injury or death. M113s are tracked armored personnel carriers, which first served in frontline units from 1960.
The detailed maintenance of the M113's engine is crucial. It's the hands-on mechanical work that keeps these aging vehicles operational in the field.
It's a combination of the tried and true methods, like the mirror inspection, and the efficiency of modern computerized diagnostics.
Built from 5083 aircraft quality aluminum alloy, this APC required 3 times the armor thickness against 7.62 millimeter rounds. The M113 exits the workshop, guided by precise hand signals from the ground crew.
When reversing, the driver of the M113 is unsighted and is guided out of the workshop by ground troops.
The soldier performs a final check on the road wheels.
Because of the introduction of Bradley fighting vehicles, the M113 was relegated to supporting roles.
One of the advantages of the M113 was its tracks, which make them more mobile in cross-country roles.
Here we see the M113 in both desert tan and the classic woodland camouflage pattern, moving in convoy through the urban environment.
M113s have a crew of 2 and can carry 11 to 15 additional personnel in the fighting compartment.
The convoy leaves the security of the facility area, with the desert-painted M113s moving onto the large open tarmac.
One of the disadvantages of its aluminum armor is that it can catch fire when hit by anti-armor weapons. To move the M113, they rely on these massive semi-trucks. The loading process itself is a delicate operation.
With a weight of 12.3 tons, the M113 is easily transportable on trucks and other transport systems.
The M113 medical variant must be carefully secured for transport, ensuring the safety of both the equipment and the personnel.
Once they are confirmed to be in the correct loading configuration, The M113s are secured to the flatbed.
The M113, a staple of mechanized forces, demonstrates its agility over challenging terrain, guided carefully by the soldier on the ground.
Dedicated loading ramps at U.S. Army units make it easier to load vehicles like the M113.
By 2024, it was estimated that the U.S. Army was still operating about 6,000 M113s, although the number was dropping.
Because of the width of the M113 at 8 feet 9.7 inches, its drivers require guidance when loading.
As you can see behind me, the transport convoy is beginning to take shape. These M113s are essential for the upcoming movements.
M113s are being replaced by mainly JLTVs, MRAPs, BFVs, and Strykers.
We are seeing the final logistics of this transport convoy. The M113 may be a legacy vehicle, but its deployment here is absolutely critical.
Mikoyan Gurevich MiG-21 fighters claimed many kills of F-105s and F-4 Phantoms in the Vietnam War.
Moving along the fuselage of the MiG-21, notice the unique delta wing design that defined its speed. The craftsmanship here is, as you can see, the MiG-21 is strictly analog. This radar scope and the mechanical throttle are a stark contrast to the glass cockpits of modern fighters.
MiG-21s were designed to replace older MiG-15s and MiG-17s, which did well in Korea and Vietnam.
In the Romanian Air Force, the MiG-21 MF-75 Lancer R was one of its top interceptor aircraft despite having F-16s.
The pilot begins the meticulous pre-flight routine by securing the multi-point harness. He then dons the specialized. Unlike modern fighters, the pilot of the MiG-21 sits low in his cockpit, providing less situational awareness.
The pilot completes his final checks. Note the insignia of the fish, a nod to the MiG-21's NATO reporting name, Fishbed.
A MiG-21 pilot is strapped into his ejection seat as the crew chief makes his way off the plane.
All checks complete, the crew chief gives the signal, and the pilot begins the sealing sequence. MiG-21 UMs are dedicated two-seat trainers, used to train future MiG-21 pilots all around the world.
The narrator captures the young adult East Asian male pilot's final checks before moving out.
Early models of the MiG-21 had their pitot tube under the air intake, while later versions had it above the air intake.
The trio of MiG-21s accelerates rapidly. With afterburners blazing, they demonstrate the sheer force required.
Even later versions of the MiG-21, known by the NATO reporting name Fishbed, have the pitot tube slightly to the right.
And with that final surge of power, the last MiG-21 climbed into the sunset, closing a chapter of aviation history.
From the outset, it was designed as an interceptor and, therefore, has a powerful Tumansky R-25.
The close-quarters flight discipline of these MiG-21s is remarkable, holding tight formation at high speed over the vast mountain landscape. Internally, the MiG-21 has a 23mm Gryazev Shipunov GSH-23L autocannon with 200 rounds. The MiG-21 demonstrates incredible agility during this high-speed mock dogfight, maneuvering aggressively against its adversary.
MiG-21 can also be armed with air-to-air missiles like the K-13 and R-60, as well as with rockets and bombs.
At its top speed, the MiG-21 could reach Mach 2 and has good dogfight handling, despite its delta wing. Helicopters like the MH-65 Dolphin are one of the most important SIR assets that the USCG uses.
From the tail rotor cleaning to the main assembly inspection, this meticulous upkeep is essential to keep our SAR aircraft rescue ready.
Aviation refueling specialists in the Coast Guard are responsible for keeping USCG helicopters fueled.
The external fuel tank requires precise alignment and securing. The crew uses specialized torque wrenches to ensure the tank is properly locked in place before flight.
Another helicopter with greater payload capacity and range is the Sikorsky MH-60 Jayhawk.
With the final checks complete and the fueling port secured, the Seahawk begins its taxi, the culmination of meticulous preparation by the ground crew.
Prior to flight, aviation maintenance technicians perform maintenance and various pre-flight inspections.
Across the United States have cars and consistent.
The MH-60 Jayhawk, the backbone of the Coast Guard's heavy lift capability, begins its pre-flight sequence.
MH-60 Jayhawks are another version of the UH-60 Blackhawk developed for the U.S. Army.
As the MH-60 taxis slowly past the static jet, the scale of the Coast Guard's primary rescue helicopter becomes strikingly apparent.
Equipped with a rescue winch, the Jayhawk has a range of 800 miles at 160 mph cruising speed.
The Jayhawk is always ready. For more incredible stories and behind-the-scenes content,